Hello. Yeah. नया बनाया.
Let's start the discussion now. Archit, just try to speak once. Let's start the discussion now. Archit, just try.
Hello. Hello. Am I audible now? And so I am still waiting for people to join because I see there's just one viewer with us. Today was some issue with the infrastructure. I'll try and fix this in the next session. Okay, I see people coming in. That is good. We see some participants joining in. Okay, okay. I'll I'll wait for next 5 minutes so that we see more people coming in because yeah, there was some issue with the session today. Am I still audible? Hello? Okay. I see few audience. Let me start the session. Maybe can you guys give me a quick thumbs up if you can hear me, you can see my screen, you can see some blue lines coming up on the screen. Can you guys please give me a quick check if uh, you can see blue marker? Okay, okay, okay. I'll start the session. Okay, and yeah, I'll start the session then. Yeah, so welcome back to the session's second part. In this session, I've started discussing about JSON, why we use JSON. So I'll start with giving a basic introduction, how a JSON serialized data look like. Right. So let's say if we have a model which contains just two fields, ID and name. Let's see how that would look if you have serialized into JSON format. So you can see that ID, then you have a double quotes name, let's say X, Y, and Z. This is how a typical JSON would look like, where each of the field is formed into a string. The field name is formed into a string, and separated by a colon is the value. And each field is separated by comma. In the end and start, you'll see a curly braces. This is how typically a JSON looks like. Now, if you see at the JSON, it looks very readable. It is easy for you to understand what data it contains, right? It contains ID and name currently, right? So that's the core benefit of using JSON. Before we had Protobuf or anything, we when we were only living in the world when XML was the only format, which we'll understand right now how XML looks like. So at that moment, JSON was a very good win. There were few reasons why JSON won the battle against XML. JSON versus XML. So in XML, the data, or maybe let's take this topic after we discuss XML because that would be little easier for you to understand the key difference why it won. So this is how JSON is looking like, right? Now let's go ahead and see how XML looks like. Now, if the same data, if I want to encode or serialize in, hi, welcome, Sashi. So, if I want to serialize this same data for XML, how would this look like? So, let's say data, and you will have ID, one, and ID, then name XYZ, again, name. And in the end, you again have a closing angular bracket for the data. Now, if you see, this XML format is very heavy when you compare it with JSON. It is still readable, not as readable as you see JSON, But the major drawback that XML had, that every field that you have, for example, ID you will see two times in angular bracket. And this XML looks very familiar to HTML, right? Is very familiar. It was, I think, inspired by HTML only. So the XML data exchange was heavy compared to JSON. So that was the major win why JSON started getting familiarized and why it got adopted majorly, right? This is the major reason why JSON won the battle against XML. So if you compare, if I would say that if I'm serializing a data in XML, if it takes approximately, let's say, 2 seconds arbitrarily, then the same data, if I'm encoding or decoding in JSON, it would take approximately 1 second. So that was the difference between XML and JSON encoding and decoding. Now, if I talk about this in terms of any web application, if you get a 100% increase in performance, or the speed is just reduced to half for encoding and decoding, not your actual business logic. It's just the data that gets encoded and transmitted, then decoded, and all those things, right? If that time reduces, your application will become faster, right? That was the reason why JSON won. Now, JSON is widely used, and it is supported by almost all browsers that you have in today's world. All those browsers will also will support JSON, and also give you some developer tool where you can decode JSON. You can write syntaxes related to JSON. For example, if you want to write some filtering logic or anything, you can go ahead and do in the any browser's developer tool. You can do it with XML, but now not all browser would support XML these days, because very less number of audience are using XML still. Then came after JSON got the battle and JSON was doing well, everyone started using it. Then is the time when people explored and YML serialization came into existence. Now, I'll show you the same data encoded in YML format, and then we'll discuss the pros and cons of using a YML over JSON. Now, if I want to encode the same data, so in YML, it would say it like this: ID1, name, XYZ. Over here, the space that you see is very critical in YML. These are single tab, or you can say three spaces. There is a syntax for that. Now, any data that you want, and let's say there is address, which contains two or three fields, for example, line one, right? So then you will have again that same space two times, line one, and then there is line two, something, country. And all this will have this repeated chunk of space. That's why YML didn't find its audience in your HTTP protocol. So not, I have never seen someone using YML as their serialization in terms of REST API. So I've seen people using JSON and the next protocol buff that we'll be discussing in later part of this video. So, but why YML, right? Because if it is so bad, people don't want to use it. Why it is still existing? So YML is a good serialization technique that helps in readability. It improves readability. Now, if you see, let me remove these blocks, and if you see a YML, it is very easy to read compared to a JSON. If you see this JSON and you see a YML, YML is very easy to read. So that's why people use YML. Still, they use YML for configurations. They save configuration. Now, let's take up some question in case you guys have any doubts till now, because now after this topic, I'll move to protocol buff and understanding how protocol buff is used. So before this, if you guys have any questions around YML, XML, or JSON, I'll give 2 minutes for you guys to start asking questions, and I'll take up any number of questions that you guys have.
Yes, Archit, I think,
Hmm?
can you tell me how the serialization happens between backend and front end?
Between backend and front end, how
I
it
hope
happens.
I was
Okay,
audible to you, Archit.
yes, you were audible. Yes, yes. So about serialization between a backend and front end application, I would say that when you, let's say this is your front end application. Let me put this up. Okay, let's say this is your front end or the web part, the Chrome, where your user is interacting with people, right? Now the user wants to save a data. He says that save my user profile, add my picture to my profile, right? At that particular moment, what front end will do is it will format that data into the JSON structure. For example, ID of the user ID, who is the user, right? Then what is the name of the user? What fields has he updated? For example, your profile picture or anything. So this is a JSON that it will form. The front end will form the JSON. To form JSON data in front end, JavaScript, you use JSON dot parse. This is a very popular syntax that you parse is for deserialization, and then there is JSON dot stringify. Stringify is to convert the object into a string or JSON encoded data. So on front end, people would use it, transmit that data over using HTTP protocol and send it to the backend. Now, as soon as the backend receives the JSON serialized data, in your HTTP header, request header, it would mention what type of serialization has been used by frontend. The frontend will always send that serialization mode in their frontend. So content type, JSON, application JSON, it would be there in your uh, request header. Backend, when it knows that it is JSON serialized, it will apply JSON deserialization logic to the data it has received, right? Then use that deserialized data or the model that the object and process the request. While responding back, it will again serialize the data into JSON format and send it to frontend. Now, to serialize and deserialize data from backend, it depends totally on your backend language that you're using. For example, people who are using Golang, the syntax to serialize or deserialize data would be JSON dot Marshall and JSON dot unmarshal. Marshall is to form into string encoding, and this is unmarshal is decoding. So people use this on Golang. In Java, other applications, the syntax would change, but the base concept of serialization and deserialization of JSON data would be same. Now, the backend would send that as response to the frontend, and then frontend again decodes and starts using and shows that data to the user. I hope my I hope the answer was clear, Devish. Can you guys give a thumbs up if you guys
Okay,
have?
thanks, Archit. And let's ask our audience if they have any questions related to JSON serialization.
Mhm.
Over to you, Archit.
Yeah. So So the people who have joined me on live, can you guys Give a quick round of thumbs up if
Yes,
you
it
guys
was
have any
amazing. I
question.
think you have explained it very well with all the practical example. Now let's ask our audience in the chat window if they have any questions related to this.
So, do you guys have any questions around JSON, XML, or YML, or how front end or back end talk to each other? Okay, okay. So let me move forward with the topic of the day, the core thing that I'm really excited to discuss about. That is protocol buffer. Protocol buffer was introduced by Google in 2008. So it is very recently compared to JSON and other serialization technique. Protocol buff is new, but it has been there for now close to 15, 16 years, and it is the best serialization. I'll tell you why. So in protocol buffer, if you serialize a data, it takes approximately less than 50% of space compared to a JSON. That is one key point. The speed of serialization and deserialization is again double the speed of your JSON. The third benefit it gives you is once you create your model in protocol buffer, you can transform that model to any of these in any language of your choice. So, for example, in protocol buffer, I'll just walk you through the code and I'll give you that demo. But if you write, let's say, a model in protocol buffer, and now you say that I want to use this model in Java, there is a code generator which helps you convert that model for Java. If you want to use it in Golang, there is a code generator that helps you convert that same model into Golang specific object. So you write your model once in protocol buffer, and that gets transformed into any language of your choice. That is one key advantage that it has. And then the major advantage why anyone would want to use protocol buffer is the speed of serialization, deserialization, plus the volume that it reduces, the volume of storage that it reduces, right? That makes it faster for transmission over HTTP protocol, over any protocol. So I've seen people using this extensively with gRPC protocol. I've not seen people using it with HTTP, but majorly with gRPC protocol. So, enough of discussion. I think we should be moving ahead with understanding how protocol buffer is working. So, let me bring up my uh, this thing, Visual Studio Code, which will give you guys a clear understanding how it works. Okay. Okay. Can you see my Visual Studio Code? Can you guys give a quick round of thumbs up or react somehow when you see my screen? The Visual Studio Code, basically. Okay, okay. Let me start that. In Protocol Buffer, what you do is you create a folder where you add all your models in a specific format. That the extension for that is Proto. You don't use go.java or C, C++, anything. You don't use those extension. You use proto specific uh, protocol buffers
It's
file
visible,
extension.
Archit.
Okay. Yeah. So now, and when you use this specific protocol now, for example, now if you guys remember the last application that we were building in our session was an inventory management application where we have three microservices. That is, first one is being catalog microservice, which takes care of managing all your catalog related activity. For example, your category, subcategory, and your inventory, basic information. Then there is a microservice that is called order microservice, which is responsible for receiving orders or like selling, buying, or return orders, all those transaction specific things. And then there is a gateway microservice, if you guys can see, which is responsible for accumulating the data from these two different microservices and furnishing it to the front end client so that the client doesn't have to talk to two, two different microservices. It only talks to one place, right? If you remember this application, there we had two models, three major models. One was the category, then was subcategory. The category, for example, for inventory, you would say category as electronics or clothing, right? And then subcategory being TV or your mobile or jean or t-shirt. These are your subcategory, right? Now, let me go quickly show you how the category actual model looks like in Golang. So this was my model, actual model that we used in in our last session. It only had two fields, name and ID, right? Similarly, if you see subcategory had name, ID, and the category name, category ID, sorry. These are the three fields for subcategory. Right? Now, to create a proto buffer, you will create a file with extension proto where you will say you will define your model with this specific syntax where you will say that the first field is my ID of what type, the second field is name, which is of type string. This is the syntax that we have to use protocol, Proto 3, Proto 2. So Proto 3 is the latest one. So we would definitely go ahead and use the latest protocol buffer encoding and decoding. We would not want to use the older ways, right? And this is syntax where we say, where do you want the final code generator to put the code, generated code, in which path it should put. So I have said that put that into a gen folder. You can see a gen folder over here. This is generated by the protocol buffer. Now, if you see subcategory also, in subcategory, one thing to note is in protocol buffer, you don't have inheritance. Protocol buffer specifically says that it uses, uh, it doesn't allow you to do inheritance, right? So that is core thing. So if you want to do extend or all those functionality, you will not be able to define your models in your protocol buff. So it gives you an option to use composition over inheritance. So that's why you see that I have said that I have a base information, which is of subcategory base information type, and then a category ID. Okay. Quick check if I'm clear till now how you are defining your .proto file. There are a lot of syntaxes you guys can keep reading about it, but is these two models, how we have written these two models or formatted these two models clear till now? I don't see any reaction. Guys, am I audible? Hello? Can you guys give a quick reaction so that I can know that if I'm audible or not? Do you guys have any questions around it? Okay. Okay. Then I'll move ahead and show you how this protobuf, the proto extension file is
It's clear,
converted.
Archit.
Mhm. How
Let's ask
this.
our audience and then we can get started ahead.
So, do you guys have any questions, any doubts till now? We are moving towards almost the end where I'll discuss how we use the code generator to generate the code from this file in Golang specific thing, and then we will move to understanding the difference between these protocols, these basic serializations. Can you guys give quick thumbs up if it is clear till now? Okay, let me move forward. I don't see people any reaction, but yeah, let's move forward. Okay, so after creating your basic models in Protocol Buff, you would want to generate Golang specific or any language that you're using that specific code, right? So then you use a specific syntax that is protocol compiler that I mentioned that you would have to install in the starting, right? Where I specifically mentioned where is yeah. You would have to go to this website and choose the specific mode of compilation. So, for example, if you're using Windows or Mac OS, specific to your system, you will download your compiler. I use Mac OS, so I use the syntax for installing the compiler for Protocol Buff. Now, let's move ahead. Okay, sorry. Now, to generate the file, we have used the compiler, protocol buffer compiler, and said that this is my input file. Where is my input files? Which folder? Where the output has to go. So my output has to go in the root directory, and then we have specified in the root directory, it has to go to the gen folder, right? So this is what I specify, and I then specify what files I want to convert or generate the code for. Now, when you say go output, it automatically understands that it has to convert that proto file into .go extension. Now, if I run this file, let me remove the gen folder so that it is very clear. Okay. Okay. Now you see the gen folder going away. Let's run this syntax and see this in microservice with Go, chapter 4, inventory application. If you see, am I not in the right path? Sorry, is API slash protocol buff. 1 minute. Sorry. I'll remove this also. Let's try this. Plugin filter. There is some issue with this. Let me fix that. Give me a moment. Let me fix this. Before we generate the protocol buffer, I'll tell you how this would work. I would restore the file for the moment. Ja- uh, okay, right now I've just put the protocol buffer files back into the system. Just I want to first take the benchmarking and show you how the benchmarking is important and how fast this protocol buffer. So what I've done is I've created a benchmark file where I've compared benchmark for JSON, XML, and protocol buffer. I want to see which one of these is passed. XML, definitely, most of us will agree that XML is not that great. So let's compare all of these. And while comparing, I would also want to compare the size of the data, right? The final output, how much volume does it take? So I've written a function that gives me the length of the data that got generated. So now let's try and run this first. Sorry, I should be in the size compare. Okay. Now, if you see what data I've serialized the same content for the category, same data, same amount of length, string, everything. Now, if you see the output, the final output, JSON has generated 31 byte of data, whereas the XML has generated approximately 57 byte, which is almost double the size of JSON, right? And if you compare protocol buffers serialized data, it is 15 bytes. It is just reduced to half when compared to JSON. So if you're using JSON and you want to move to protocol buff, I think this should be a very nice thing to do that, right? Now let's compare the benchmark for this thing. Let me run the benchmarking. So what I've said is run the benchmark for 10 times for each of the function. Now in the benchmark, if you see what I have said specifically is that test the serialization in JSON, serialization in XML, and serialization in protocol buffer. So let's go ahead and see. Okay, it has almost completed. Okay. Now, if you see the difference between the time. So, for example, for JSON, we were able to compute how many operations? Almost 10 million operations, right? In the said same time, almost close to 10 million, 10.5 million operations, and each operation almost took 100 to 110 nanosecond. When you compare this with XML, XML was not able to complete even 1 million operations in the same time frame, and it used almost 1300 nanoseconds per operation, which is, I think, 10 times, almost, yeah, close to 10 times of what JSON was consuming, the time, right? Now, if you see protocol buffer completed close to 19.5 million operations in the same time window where JSON was able to complete 10 million or 10.5 million operations. So that means I was able to complete almost double number of operations in the same time window. Now, why is that? Because it consumed only 62, 63 nanoseconds per operation. So if you compare it with the JSON time, it is almost half, right? So that's why protocol buffer is so important and is being used in our modern day application where we want to do a microservice to microservice call. So that's why people want to switch away from using JSON for your internal service to service communication. I hope this was clear. Any doubts, any questions, anything that you guys want to ask? Hello. Okay. I don't see any questions around this. And with this, we have almost come to the end of the session. I would open the ground for you guys to ask question. Yeah, let's take 5 minutes for you guys to keep posting your questions or any feedback that you would have for me. And I would be pasting.
Looks good, Archit.
Looks good. So, Devesh,
Are
for our
we
audience,
done for
can
the session? Do we have any pending topics, Archit, or
no,
should we
we don't have any
wrap it
pending
up here?
topic. Mhm. We don't have any pending topic. With this, we have almost come to the end of the session. I Okay, okay. I think we don't have any questions or anything. So yeah, I'll share the notes of today's session in the GitHub. I'll share the notes on the same GitHub that I've been doing, and I'll share the GitHub link again in the comment section of this video. Also on the LinkedIn. If you guys have not followed me on LinkedIn, please do follow me because that is the place where I keep informing or keep posting about the coming sessions. So it would be a good place to keep in touch. Okay, okay, guys. So then that's all for the day, and see you next week. Bye.
And Archit, kindly ask the audience